Thank you very much. Thanks, Matt. Yes, whether you like it or not, you are part of my birthday celebration today. A lot of people have said to me, oh, shame, you have to work on your birthday, but honestly, being on the stage at Demuxed is a great way to celebrate my birthday, and it's a pleasure to be here. I am going, if we get my slides up, to talk to you about creative monkeys contemplating dating. Now, if it's your first Demuxed, you might say, wow, that's pretty creative. He's using monkeys to talk about data. But if it's not your first Demuxed, you'll be a bit disappointed. Like, Will, you've done that before. You've done the monkey thing. And that's true. But in my defense, this was not my first title that I wanted to use. The title I wanted to go with was Threesomes Are More Fun. And I had to scrap it for two reasons. Firstly, it's not very enterprise friendly. And secondly, I'm a video engineer, so I don't actually know if they are. But it sure sounds alluring, the notion of sharing with multiple partners simultaneously. And it's the data side of sharing. So sharing data with multiple data partners is what I want to explore with you today. So with that context in mind, let's begin Common Media Client Data version 2. So I spent a lot of time working on specs. Some of them go nowhere, but some of them have actually become popular pretty quickly. And CMCD has been one of them. The growth, CMCD began back in 2018 with a suggestion at Mile High Video Conference. At CTA Wave, we started the work group in October 2019. We released it just over a year later, and then we got a bunch of player support quite quickly, culminating in AV Player in June of this year. And CMCD is useful when everyone's using it, and we've reached the stage where we can gain generalized benefit from CMCD. And I was excited even at IBC this year. There were a whole lot of other conference sessions organized around it, product announcements. We've really created an ecosystem around CMCD. So we could be done, right? We could end right there. We could go to Colleen's party early, and life could be good. However, we did file a lot of bugs in the interim. So while people are deploying and working on CMCD, we realized there's some bug fixes, there's some definitions that need tightening, but there's also new features. And those new features are quite exciting, and we wanted to get onto them, right? Because we began to see what we could start to do with players sending data. So we opened up version 2 of CMCD. The work is underway currently. So what I'm talking to you about is not in the final standard. We're about halfway through. There's still time to change things. There's still time to improve things. If you want one slide as a summary, here are some of the key changes or the field names in the standard. And I'm not going to read through all of these. I want to explore several of them in different opportunities. So the first of this revolves around buffering. So in CMCD1, we report buffer after the fact. And all buffer events look the same irrespective of their size. So if you tell me, oh, I saw a monkey, did you see a big monkey or a little monkey? Doesn't matter if I'm monitoring monkeys, but it does matter when I'm monitoring rebuffering in my player logs. So here we see two rebuffer events, but were they 200 milliseconds and the user didn't notice? Or were they 2,000 milliseconds and the user did notice? So to address that problem, we introduce a new parameter, which is now buffer starvation duration, BSD. And as its name suggests, you simply add it in after you report a buffer event. You can say my buffer lasted so many milliseconds. And your analytics system simply takes the session ID, sums up all these buffer starvation durations, and then we have the total amount of time that our player rebuffered for. So a simple system, but much more accurate rebuffer reporting with CMCD v2. Now, we have two other parameters that are both Boolean operators. One is called BS. We did make a spec with BS in it. That stands for buffer starvation. And the other one, SU, for startup. And we put them in for startup if the player is trying to start up, either initially or after a seek or a rebuffer event. And we put the buffer starvation in if they're rebuffered. And this all works well. And in our thinking, well, the player is going to add them. However, all keys in CMCD v1 are optional. So if we have a log field like this, where there's no SU and no BS, does it actually mean there was none of either? Or does it mean that the player simply never added those tokens in the first place? And this, in production, causes a problem. We want reliable monitoring, and we couldn't tell the difference between unreliable players and players that were having a good session. So away with the naivety. With V2, you have to report the BS if it's taking place, and the same with SU. So now we can trust any incidents, or more importantly, we can trust the lack of one of these reports as a positive signal. It does mean we now have required keys in CMCD v2, and they are the version, which you must ramp up to version 2, SU and BS. That's it. They're the only required keys so far. More buffer monitoring, because buffering is important to us. So with CMCD v1, you can report the buffer length of the player as it's going along. So let's say we're looking at a population of 4 players, A, B, C, D, or yellow and other colors, and I ask you which one of these players is having the worst time, which is performing the worst. And most people would say, well, it's the one with the lower buffer, surely, the yellow one. But there's some additional information I could supply. Like that player actually is a low latency player just trying to have a 3-second buffer. We got live players, we got VOD players, and we even got a long form VOD. So what's really important in interpreting buffer length is knowing something about your target buffer. What buffer are you trying to reach? That is important in scaling the value. So we are introducing a new property called target buffer length now, and that, as its name suggests, it's the target the player is trying to reach. And if you look at some of the config settings for popular players, and I put them up here, you'll see behind that there's a lot of opportunity to define and to set these buffer targets. They're not static, they change with time over the life of the player. So the data's there, we just need to report it. Now that we can report it in V2, we can shift from this graph, which is the original, we can normalize the buffer length by dividing it by its buffer target, get a percentage buffer fill, and now that blue player stands out, and we can see that actually the long form player is having the worst time. It's performing least well compared to the other players, which are doing okay. Another aspect we like to monitor for media players is their start time, right? And in CMCD v1, I used to tell people you can approximate your start time by taking the wall clock time from when you first load the manifest to when you've loaded the third media segment. And this is a pretty good approximation, but the question is how accurate is it in real life, and how can we improve it? So let's look at a loading trace for an actual player. We've got video buffer on the vertical axis, and we got time elapsing on the horizontal axis. In this case, the dash player HLS doesn't matter. We load our manifest, we load our audio and video inits, then we load our first set of audio and video segments, second set of audio and video segments, third set, and the fourth, and so it continues. This is very typical. So with the CMCD v1 analysis, we would guess that the player started roughly here. It had loaded 3 media segments, and that's the time, and we would guess it was 748 milliseconds. However, media players tend to start faster than that because they're scored on how fast they start. And this angle here is the ratio of how quickly I'm filling my buffer relative to how quickly time's elapsing, right? The faster my throughput, the steeper that angle is going to be. So if the angle is steep enough and the player is confident that it won't rebuffer if it starts playback, it will typically initiate playback right after it's got some fraction of that first segment. And this player, in fact, started at this green line right here. So we want to capture that. So now with CMCD v2, we have this something called media start delay. As its name suggests, it's how long your player took to start. And it would track exactly this point here. So this player is actually doing 200 milliseconds better in startup than we would otherwise give it credit for with the prior reporting. Now we have another property we're adding in v2 called state. The notion of what state is our player in, and it begins in a starting up state. And starting up state begins from when the user initiates some type of playback to when they first see audio video content, or they can consume audio video content. It's actually rendering. So that aligns precisely with this media start delay. Your startup state is true from time 0 to your media start delay, and then after that you switch into a playing state. What's interesting and that I want to point out is the startup parameter, is this one, stays true for longer. And that's because startup should really not be thought of startup. Gwendal suggested a good name for it, service urgency. it's basically telling a CDN, I really need these segments. I need them because I'm trying to build my buffer after some event, and I want to continue building my buffer till I reach my buffer target, which in this case was about 12 seconds. So SU stays true until you reach your buffer target, and then it becomes false. And there's a difference between the startup state and the SU true state transitioning to false. So it's understandable when you see it on a picture, but it might not be understandable when you read it in the spec. Right. A new reporting mode. So the really interesting stuff in CMCD v2 is coming with the invention of new modes. So modes are boring to talk about, so I have a monkey that represents my player. I want to be as cool as Tom, so he's actually sitting on a Hardeman box. I think that's the right term, right? Or is he superimposed on the box? I'm not sure. My monkey is sending data to the CDN, and it sends it, come on. It should be sending the envelope right over there. He sends there he goes, thank you very much, PowerPoint. What he's sending is my CMCD v1 request, okay? And this is known in v2 vernacular as request mode, and what do you get back from the CDN? You get a media object, which is that package that's flowing back to his box. But every time he receives a media segment coming back, we know some information about it. We know the response code that it came back with. We know the time to first byte, the time to last byte. We can take this richer information, bundle it up with the original CMCD data, and report it to a new location. And that location we'll represent by this machine over here. And now what our monkey's doing is sending data simultaneously to two locations, both using the CMCD format. The difference being this path here we call the response mode. Why? Because it's sent after we receive an object and after we've enriched the CMCD data with the information that we get in the response. It might be that I got a 404, right? Which you never know when you're requesting it. These two modes can happen simultaneously. They can also exist by itself, right? So I can get data from a CDN. I'm not sending any CMCD data to it, and I can send it using our new mode, response mode, over to my third-party data collector. So they're optional, right? And that first mode, the request mode, is the default mode. It's always going to happen in a player unless you turn it off. But you can turn it off and enable this second mode. So a few details on the response mode. Because we're decoupling it now from the actual request, we need to give the analytics engine some information. We need to know when this request took place, and also what were you trying to request, the URL. So simply add a timestamp in a URL field. So the white keys are just copied over from the original request. The yellow ones are ones that we're adding. We're enriching the data, and we're sending it along. And that's what response mode looks like in CMCD v2. Now we can decouple things, right? With CMCD v1, you get your data with your CDN logs. We try to make the logs small, but here's a typical log line, 691 bytes. If you're monitoring a large cohort of players, say 100,000, that's just under half a gigabit per second of log files that you have to process just to extract your CMCD data, and that's quite a lot. The data itself would be 80% smaller. So what if you want to monitor the health and status of your players, okay, independently of the requests? So I don't want to know about every single object they're requesting, but I do want to know what their buffer is and are they healthy. And I want to do it without parsing and collecting CDN logs. I want to know what the state of the player is, and I want to know critical QoE properties like their buffer status, their throughput, and their bit rate. So for this, we have a third new reporting mode. So we have our player active here. We got CMCD request mode. We've got the response mode. And basically, we can add a third data collector in, and now we can send information over to a new data source. And it's hard to show it in this animation, but the rate at which it reports data in this state interval mode is different. It's not request bound. So I will explain where and when. As its name suggests, we report data on every state change in the player. We also report data at some heartbeat interval that you define. So if you want to report every 30 seconds or every 10 seconds, you can get it. You ask me, well, what are the states we're defining? These are they. They're pretty generalized. You might say there are a few more states I can imagine for my player, but these are general buckets that most media players exist in. And because we're decoupling it from the actual segment requests, you can't use some properties with this mode that you can use in your requesting, like the duration. You don't have an object you're fetching, you're just saying what it is. So not too complex, you report a subset of CMCD, but it's still valuable. Content steering can be one of the main benefactors of this state interval mode. Imagine if your steering server was also your state interval data collector, right? So with current content steering, you just get information on throughput. But if you used state interval mode, you can now get all the additional information I get here. And this gives you makes much better decisions happen in terms of steering players, right? You have more information available. And state interval mode, like the other modes, can exist independently of them. So it can exist by itself. And 2 points to note here. One is that if you're reporting state, you change state quite quickly at startup. You don't want to be competing with startup resources, so you might want to batch it. Okay? You might want to report it after the fact. And you can say, well, Will, how do we batch stuff? So we called JSON post the neglected child of our first data relationship. We had no way to post our JSON, but if you look and squint your eyes at this JSON, you'll see it begins with an array. So we simply put all our various reports. So in response mode, we've got 2 reports right here, and for each of them, we're adding in a timestamp and a URL. So we can send this after the fact, and then our analytics engine can reconstruct the timeline that the player was experiencing. And same for state interval mode. We can batch those. Here we see 2 reports coming in. These are state reports, and then 30 seconds later is an interval report, and those all get batched off. And to configure this, you need to tell your player which modes do you want and how should they operate. So here we see this is -JS, and the request mode is the default one. We just basically turn it on. Here we have response mode, and we're telling it which keys we want to use, because we can control that, and we tell it where to report the data and how to report the data. Similarly, for state interval mode, we're telling it to report every 10 seconds, and maybe with a different set of keys, and maybe to a different target location. So the player configuration expands a little bit, but it gives us a lot of control and utility. Now, the question you should ask is, does all this work, right? You can draw whatever you want up in a spec, but does it actually work in the real world? So if you want to find out where stuff works, where do you go? So I went to Uruguay, not literally, but figuratively, to Montevideo, and the good folks at Qualabs, particularly Nicholas and Santiago, who engaged on this project, and I want to thank, because they built out a test bed that we can use to experiment on all of this before the specs actually finished. So let me walk you through what we set up. We have Akamai CDN. I also have Akamai Cloud Compute that I monitored it on. That little QR code may or may not give you $100 free of hosting if you ever, you can't scan it now, but you can scan it later. And on this, there's a web page generator. It's got -JS player, and it's going to hit a proxy service inside this analyzer. And the proxy service will intercept the requests for the content. It'll strip off the CMCD data, and then it'll basically return the object to the end user, to the player. At the same time, it'll act as a data sink for the response mode and for the state interval mode. So it gives us a consolidated sync for this data. We go into Elasticsearch and we throw in some Kibana, and now we can monitor what we have. So let me show you this working in practice. Here's the page generator. We're going to load up Big Buck Bunny because that's required for Demuxed. And you can point it obviously at where your script is running and the port, and then you can generate URL. What it's going to do is instantiate the player in a web page. This player actually preloads for startup to improve its startup time, or reduce the startup time, so I have to start it playing. And then the interesting stuff starts happening in the JavaScript. So we see a mass of requests going out here, but if we focus on the actual media object request, we see our CMCD data attached there as we normally would. But now if we filter for response mode, we'll see the requests going out to that response data collector. They're also carrying a different subset of CMCD data, and our state interval. So all three modes are happening concurrently at the same time. Now, I don't have Netflix's cool client simulator, so I go through the time-honored tradition of reloading my client a few times to generate 2 more clients, which I'll do right now, start them up. And then after I start them up, we can switch over to our back end and see what that's looking like. So we've got 3 players now sending 3 sets of data in these different modes. So here's our Elastic interface, and we see our data coming in quite happily. If I go and filter it by the mode, because for this test object, we're collecting everything in the same place, I can filter by response mode. We'll see our response data coming in. I can similarly filter on state interval. We'll see our state interval muxed in with it. Now, obviously, humans aren't very good at reading data tables. We prefer some type of dashboard. So we mocked up a simple dashboard here that's going to monitor our players, which is typically what we want to do. So here we have an aggregate view of the measured throughput of all these players. We can see the bitrate being loaded. We can see the buffer length, object types being fetched. We have 3 players. And I can then go in and filter on any one particular player, which is super useful because we have a session ID in there. I can go and dive down and track individual sessions playing. Now, state interval mode allows player monitoring, but what if your player doesn't make requests, right? And what if it makes subscriptions? And so I wanted to do an experiment with the other project I'm spending a lot of time on, which is media over quick. So can we use CMCD2 with media over quick? And I think we can. So I take the same test bed. This time, we're only going to use that state interval mode because it's the one that's decoupled from the other objects. And I'm going to use a mock relay. This is Jordi from Meta, so I'm using Moxygen's relay. Thank you, Jordi. And then I wrote my own player. It's a modification of his that allows me to trace out the time. So it's speaking via Web Transport Protocol to the relay, but then I'm going to report the data with HTTP. And the reason for that is when we roll mock out, I don't want to have some data collected in mock and some in HTTP. I want my HTTP collector to get all the data. Eventually, I can transition over to mock collecting it all, which is another Demuxed talk sometime in the future. But for now, I want to consolidate my data collection. So let's take a look at what that looks like. So here I've got my mock encoder. I'm going to start it up and start publishing. We need to go copy the track name. I'll copy the track name across. So this is web codecs, do the encoding, web transport going out to mock. Here's my player. If I put in the track name, I'm in Zurich at this point, and I'm talking to Madrid. And here we see my stream starting to play in media over quick. But importantly, on the side, I start to see my requests going out to my CMCD proxy. And I invented some new keys here. I put in reporting a latency, but also max latency and a min latency, because I want to capture very tight perturbations. Latency in real time will drop for a frame or 2 and then recover. So we go back to our database. We'll see our state interval reports coming in. And then I wrote a custom dashboard. Again, I can filter it for that current session. And I'm able to view my latency. So the 3 lines on the side is my max, my min, and my average latency that I'm getting from this stream. And I've got the stream on the right, and I've got my monitoring system on the left. So CMCD works out quite nicely. And in fact, if I take a screenshot of that over time, I got perturbations in my latency that I was able to accurately capture with CMCD on the left-hand side. So it is a viable monitoring solution, and I think quite an interesting opportunity. I encourage you to get involved. As I mentioned, the spec's not complete yet. It looks like a Google Doc that's being edited because it is a Google Doc that's being edited. You too can join. If you belong to Wave or SVTA, you can jump right in. There's a QR code there for the project. And Qualabs have open sourced everything that I used in this demo. So they've built a little microsite that goes above and beyond. It explains the 3 modes for CMCD, which is fantastic. Then there's a demo section. They've mounted that proxy and the player on an instance for you to access. So you don't have to actually install anything. Then if you want to install something, there's a link to the Analyzer repo and the CMCD repo. And finally, 2 videos showing you how to use everything, so they could not make it easier to experiment in this field. There's a link there. And with that, there's nothing more for me to do than wish you happy data sharing. So thank you.